is the idea behind the planning. Like, because normally anything happen with a plan, even you building a house or a plan on business, opening a business or whatever it is, there will always be a plan. And it's exactly the same applying to in networking. You want to build something, you want to update, you want to upgrade your stuff. It's coming to the first as planning. So plan is one of the crucial part in the journey of anything, I guess, and it's applied the same here in networking. So here we just a little bit of introduction into network planning and design. As you can see here, it's not just planning the whole and complete newly designed, even an upgrade of the existing network. We still need a plan and make a detailed plan on how you're gonna update or how you're gonna install or implement the whole networking. Okay, so first always come up with a plan or anything, and second one, just to let you know, mostly the technical decision is usually the part where thing gone wrong with all the planning and stuff. Because technical part, you don't go and say, okay, this one is cheaper, we take this one. It's not how you decide for the technical point of view. It's coming from the requirement, coming from all perspective, even from business and money. That's how planning in terms of networking is more. It's taking time to decide the best fit for what you are going to need and to serve the purpose you plan on building, because you want to, when you build a network, you plan on serving or solving something. And those technical decision is make sure it the best fit for the goal you want to achieve in terms of building or designing the new network. Okay. And like it said here, you will regret it one if you don't make a good decision with all the issue that's coming up after you already decide everything is messed up, right? So make sure you plan well. That is one of the part that having a lot of discussion, meeting, following up, meeting with CTO, network engineer, administrator, infrastructure, and everything. So it's take a lot of energy and time to make those technical decisions and understanding the advantage, the benefit from different perspective of the networking, right? So this to just to a bit intro. Here in general term, like we said last time, so it's just a general definition of network planning. So like we said, the network planning approach is to address the problem, right? You have some problem, you have a poor connection in your network, in your company, in your enterprise, you need to set up a new connection, or you don't have a network yet because everyone is just using their personal stuff and you don't have a network in your enterprise yet. You want to set up a new or update a whole completely new planning for the network. It's all coming down to the planning, right? So those are the problem we are trying to address. The problem that you don't have enough node, you have a costly network topology, you have a problem with the slow connection, with a slow throughput of your network, and all those stuff. So that is the approach of that we want to solve, the problem we want to solve. Okay. So here, the goal of the network planning is to interconnect, right? Different equipment. While equipment here is referred to the device, the node of the network, where not just your computer, maybe different device you use in the network, even from a printer to to a server in your system, right? And here I like to point out these three part where mostly we want to consider of, because most, if you are not aware of this, normally it's not just you wanna buy a computer, you go and buy a computer of your own with the money you have. You don't consider what you're gonna use your laptop for. You just buy $1,500 laptops, and you use Facebook, and then you watch YouTube on that, right? But when in coming to the enterprise, the business point of view, it's wasted, right? You use a $2,000 laptop for something that is not useful, that doesn't turn into the money you're gonna make in terms of enterprise, because in the business point of view, you wanna do something that is going to turn over the money, right? And that is what you have to consider, right? So in terms of business, when planning a network, three main things that usually have to be considered, and the most important one, of course, is the cost, right? And network planning is where this thing can become, the focus of your planning. Sometimes, because it depends on the business, the network of the business decide, okay, we want a network in our enterprise, in our company, and we don't have much money, so we want to minimize the cost as much as possible. That is how your planning will be decided, will be based on those decisions as well. So this as the factor you have to consider as a network engineer to who plan the network. If you say the cost is the main factor in your network planning, the planning will base solely on the cost of the network as well. And if you are in case of a big enterprise, mostly cloud infrastructure company who build cloud infrastructure, distributed system, minimize delay will be the core business of their networking. So here cost will be in the second or the third one. You still want to reach the highest capacity so that you minimize the delay in your traffic, or maximize the throughput in case you are in an ISP. Money might be the second part where you have to consider, but the throughput will be the first one where you have to make sure that you have the highest throughput possible for your customer as an ISP, as an internet service provider, all right? So there are different kind of companies having different factor in consider of how you plan the network out. So it's really, and those three really affect on how your planning will turn out, or how the actual implementation, the device you use, the technology you use, the software, the application, and all that will be solely dependent on those important factor of the network design and planning, right? And it is very crucial. And although here is in the intro, in terms of business, it's very important, right? So here is something you have to think about generally. It's not just here, maybe it's depend. So don't rush the plan. The planning is one of the, like I said, it's the crucial part, and you have to go through a lot of meeting, a lot of discussion, a lot of discussion in order to come up with the perfect plan for what is going to happen, right? So never rush. Although I would say don't rush any plan, or because the planning of anything will be the initial part that you're going to screw thing up, right? You rush the plan, you're gonna screw what is coming up, anything, right? So make sure you think it through, consider different approach, thing that we can do. What is the other way that we can achieve the same thing using different thing, and how those things will be different from each other, the advantage, disadvantage, money, and all that, right? So that is something generally you should think about. And second one is write down the plan. You don't remember everything. You are not a machine. So anything, you should come up with a plan. And the writing one, document every detail on how it is going to happen and all that, right? The third one is to keep the plan up to date, right? It's because normally you don't have a perfect one. You know, although I would say we will want to make the first design, the first planning going the way we want, going the way we want to see it perfectly fit with our network, but it's not going to be, so be aware of that. So there will be always an update, an upgrade of your system, of your network topology and everything. So make sure you always keeping up, keeping up those plans up to date. Every time you have a new update on those things. So here's just something generally you should think about in terms of any planning or design, and here specifically for our network planning and design, right? Being purposeful. Okay, this is just something to point it out. Like I introduced you earlier, the goal on why we want to plan, why we want the network. Why is it necessary? Do we need to do it? And it's really important because somehow some people we just want. I start up a company. I just want a network, right? You don't have any actual plan or actual purpose of having those network. So you need to have a purposeful of. You need to be purposeful about what you want to design for, right? It's the first step here. They say it's one of the first step in planning your network. So it is really quite important on that. The next one, the next part is taking stock or understanding what you have. That this is one of the initial challenge in any planning or any upgrade. First of all, we don't want to waste a lot of money, and we don't want to waste a lot of time on building this thing. So you have to understand what you already have in place. Normally, even though you just start up a new company, you don't just okay, I want to build a network, right? Normally, you already have some people, you already work on the business, and then all of a sudden, you have a lot more people coming up. You just give everyone a laptop, everyone working from home with their Wi-Fi and all that, and then now everything is going to normal, and you need your working space. Then you plan your network. So before you go to plan the network, you have to already know what you already have in stock. You have the laptop in stock already. You have the printing device already. What you don't need else. You already have your cable. Maybe you already have an access point. You already have uh, the switch or whatever the device that is going to involve in the network. Because taking stock is understanding our inventory is the biggest part where you're gonna save your money, where that is where the cost is add up. Most of the company, when they wanna build or update a new network, they don't buy everything new, right? They have to know what they already have in stock, what they already have in their ecosystem. They already have the cable, maybe they already have the switch or the router, maybe, or maybe they already buy a external gateway from the NISP. So all those things has to be taken into the consideration of understanding what will be the next step of using those stuff, because you don't want to waste all those things when you set up a new network. So you're gonna waste a lot of money. So having those stock, knowing what you already have, document everything so that you know what you already have. And when you plan out the network, you have to also consider something you already have to use in the new network, so that you don't waste a lot of money buying all those new things that's going to waste, right? And taking stock is knowing every detail, document everything that you have in your stock, in your inventory. It starts from, maybe you have a lot of computer already, or a lot of laptop you bought for your customer, for your staff, for your people in your enterprise already, but you don't already have a network. So you might have to consider what you already bought for them, right? You have to understand. So as a network engineer, you have to know every little detail of all those devices, right? The processor type for those computers that you already have, the clock speed, the size, the memory, the operating system, the I/O device you bought for them, the mouse pad, uh, the drive, all those device that you already have to be taken into the consideration, so that you will use every little bit of it until it's gone, right? That is the motto of the business. They want to squeeze everything to the maximum, so that they use up to the price that they already pay for all those stuff. And software used by each device, it's refer to the application on the device that you're going to use. So this also the solely part where you have to understand, because it's going to affect on how the device you bought for your staff, for your people in your working place. For example, if they are working on the administrative thing, working on Word, Excel, not many computation, not much of a, you know, processing going on, you might consider having a lower type of device or laptop for them, because you don't want to waste a lot, like $1,000, $2,000 on a device that you just gonna use for Word and Excel. So that is really something to think about. If you have an enterprise, and one part of your stuff will be an architecture, who going to do a lot of drawing, a lot of architecture stuff with their application, Adobe, and all that. So you might consider having a better laptop for them, or a better device for them, because they're going to use heavier planning and heavier computation and processing in their device. So it is also something to think about. You might think it's just one or two laptops, it's not much of the money. But when you have a bigger company, you have 100, 200 stuff, it's going to take up a lot of money, right? 500, 10 times, it's 5,000. So it is something to consider. So the laptop, the device, and everything have to be considered to the maximum of the use, and understanding the application we are going to use on that device, so that we have the perfect fit for the perfect people, for the device, for the software and application that they use. So, and as a network engineer, you have to document everything. You have okay, how many laptops do I have? What are the spec of them? And everything. Everything, I mean everything. All the detail of all those stuff, right? You define specifically what are the people that are going to join your enterprise. How many of them will use this application? how many of them will just use this application, and then consider what will be the best thing you can do for them, right? And also cost you less money in terms of business. Okay. After you understand what you already have, you know the idea why you want to build your network, you know the priority, whether it is money, whether it is throughput, whether it is the latency of the connectivity in your network and everything, meaning you have your basic cover up, starting from knowing where you want to go and knowing what you already have. The next step will be planning the network topology. So I'm sure you are already aware of network topology. So here just a summary on what you should consider and what is topology refer to. So network topology refer to the way the device in network, how they connected with each other via the network, or via the wireless or whatever it is in your network. So topology is like seeing, you see where your device, you can imagine how your device is going to connect with each other, how they're going to be using, and really seeing every detail of where your computer is and how they connect to your server, how they connect to the switch, how they connect to the internet, and all that, right? That is a topology. You will need to determine what kind of switch you use, how many you are going to use, the cable, how to run those cable, where to locate switch, where do we put switches in the server room or in the plain space with the office, and everything. In this stage, it involves in defining the place of each component and how they will connect with each other. So that is the general idea, right? The place of each component in your network. Component here refer to the device, everything, the server, the node, the switch, the router, the bridge, the hub, all the device in your network, and how they will connect with each other, right? So this is topology, the network topology. So the topological, or here you say the optimization of how to optimize your topology, right? So topological optimization method, and if you have heard of graph theory, so graph theory is one of the mathematical theory where they consider the fastest way to reach something. I'm sure you have already learned about graph theory in discrete math, in your discrete math course. So in this network topology, it's actually coming from that idea as well, where when we want to build a topology, we want to optimize, we want to reach the optimal state of how everything will be connected with each other, right? And here they say this method involved in three or four main points of that. One is cost of transmission, cost of switching, and thereby determined by the optimum connection metric, all right? Location of the switch and concentrator. So these are things that will affect or will be having to consider about the topology, because if you choose different topology, those topology will affect on the cost of the transmission, the cost of how you're gonna switch around your packet, your traffic, and connection metric and all that. So location and all the thing, it's going to affect your whole network, right? Okay, here is some general question you can think about. It's it's something you usually see or already, I guess. So in our lab as well at ITC. So you might see the server room, and you have a device in different room and all that. So it's one of the things you can be considered. So here's some of the questions you might want to think about. So what is number one is where will the server be located? Okay. So normally server will normally have a server room because the room have might be different depending on the server itself, the connection, the network device that is going to involve in that server room and all that. Because they also gonna use different kind of aircon for the server as well, because it's depend on the type of the server, the computation one, the graphical computation one, or just the DNS normal server, or just a small DHCP server, right? And another one is where will you place the working switch, the working group switch? Okay, so if you see at ITC, if you go into each of the lab room, you will see a switch at the back of the room, right? So here you can see the switch inside of the room, exactly where the node is going to be. Node here I refer to the computer in place. But in some section, you don't see the switch. The switch itself is in the server room, and you have to run your cable all the way from your room to the server room, where you have a lot of cable, because one for each of your computer, of course, and then it will be a long way to the server room. Whereas you just put the switch in the room with the node that you are going to use, and then you just use one cable connected from your switch to one of the switch or the router in the server room. That way you only use one long switch, right? Sorry, one long cable to connect from your room to the server, whereas you're going to have the switch in the room, and then you have a lot of cable, a lot of long cable running from your device to the switch in the server room. So it is also something to think about. How many client computer will place on each working group switch? Okay. So normally you have a 24 or 48 port switch. So this is something you should think about. Like, but also you have to consider the price here, because the 48 port switch is quite more expensive than the 24 port switch. So the price here will also something you have to consider, where the client computer, like how many client computer that is going to sit in one place, and the switch we are going to use in that room, right? They say if you need more than one switch, how will you connect the switch to each other, right? So this is also something you have to consider. Should you have the switch in each room and one of another switch in the server room, and you just connect one cable to the server room and all that? And if you need wireless networking, what kind of wireless networking device you need? Meaning the access point device, and where you will put them. So this is also you have to think about, because in terms of the frequency distributed by the access point, it's going to affect on different side of the device that you are going to use in your network, that is going to affect, right? Maybe you get less service in this side, you got a lot of service on that side. That's also is a part of planning your network topology. So here I'd like to point out what are the different thing that you have to consider about topology, because the choice of topology for your business is going to be influenced by different factors, by different components, especially depend on your business size. And most important, being the size and the scalability of the network, right? That is actually the main thing where the topology is going to affect on how you plan your network. Because different topology, they have different advantage and disadvantages. They have different benefit and cost of each topology, and they will be different from one to one. And this will affect the size and the scalability of your network. And like if you have a network and a small network, a coffee shop, it's not going to expand much, right? Because you have just one shop, you have a Wi-Fi, and then just for some device in your small shop, and that is complete. But whereas if you have for example, you have an IT solution company, you have a lot of developer in your enterprise, and all of a sudden you have a lot of projects throwing coming to you. You need a lot more developer. Then your network is going to expand a lot more bigger, and it's depend from time to time, because sometimes you'll have less project, so you don't go and fire the developer and all that. So this is something you have to know, that will the network be scalable when your company will reach different size or the maximum size of your network that you cannot handle, or and all that. So these are the two important things where you have to consider. And they also mention cost here, so cost is also one of the influent part of that as well. Even though you know that your network is gonna scale to one of the big chunk company, but you don't have much resource now, you also have to consider that as well. And here they say the long-term factor, including configuration management, monitoring, general performance. So these long-term factor, meaning where the management part will come in and do the update and understanding, monitoring, and having to update and all that, right? So it will affect as well on how you manage your network after you implement it. Okay, now let's talk about different network topology that you already learned. Now, okay, let's go back. Okay, I'm sure you already learned about network topology uh, in the last semester. Now, can any one of you share me what different network topology you know of, right? Okay, give me a minute. Okay, the Miss Noe, Tony. Okay, now I share you a link to the whiteboard where you can write down what are different topology you already learned, right? So click on the link, come onto the whiteboard, and type different type of network topology you already learned. Go on. នេះយើងខ្ញុំ share link ឲ្យឥឡូវមិញយើងនិយាយអំពី choice network topology និយាយពីអីមួយចំនួនអញ្ចឹងខ្ញុំចង់ឲ្យពួកយើងទៅកាន់ចូលទៅកាន់ whiteboard ហើយ type មើលតើមាន network topology ណាខ្លះដែលយើងបានស្គាល់ឬក៏យើងបានរៀនហើយ I'm sorry, I was speaking on mute. Okay, I saw somebody writing mesh topology. Star topology. Mesh topology normally is not used much in terms of network in an enterprise or business because if you are aware of it, mesh topology you have to pay a lot for the keyboard and all that, and it's not very effective in terms of scalability and configuration, right? Mesh topology is not normally used in an enterprise. Okay, you say there's a bus topology, ring topology, star topology. That's good. Tree. Okay, there's tree topology. That's good. Hybrid topology is you will see no it's used in quite a lot of different places because hybrid is the one with the scalability is seen as a good topology for for the update and all that. Scalability is good for hybrid. Bus topology is also one of the famous topology, but it's normally used in a small network where throughput is not something a priority because bus topology you're gonna share channels in your network, so it's going to cost with your throughput and the bandwidth of your network. So ring topology, yep. Star topology is used a lot. I actually also have an example where the network in an enterprise using star topology as well. Okay. Anything else? Anything else besides this topology you already write? Anyone else? So you already have a bus, ring, star, mesh, tree, hybrid, ring. Okay, that's good. Point to point, that's good. Yep. Point to point connection is if you are aware of it, point to point connection is now being very popular in terms of in blockchain technology where they use this kind of network configuration to connect different device for point to point or peer to peer network. So it's a good one. And point to point is not possible to use in a in an enterprise, right? So anything else? I saw one fully connected. You can open your mic and talk. You don't have to type everything. Okay, what the difference between mesh topology and what? Fully connected one. What do you mean by that? What is the fully connected one? You want to The fully connected one refer to the peer-to-peer thing, the peer-to-peer topology, because peer-to-peer topology is the one that everyone have to connect it with everyone. So there is a lot of network going on, right? That's might be something you mentioned, the fully connected one. But maybe yeah, maybe the peer-to-peer topology. It's different. It's uh how do I say? Have you what is the advantage and disadvantages of this tool? Okay, good. Somebody show a type of network topology, and with a good example as well on the picture. That's good. Okay, thank you everyone. I'm sure you already heard a lot about this network topology as well. Let's go back to our slide. Okay. So here I list out some of the network topology. Some of them you already mentioned it. So you have point-to-point or peer-to-peer topology. Daisy chain, you haven't mentioned it, but it's not much. Bus topology, you mentioned it. I'm sorry, here I have star topology. It's star topology, ring topology, yep, mesh, hybrid, and tree topology. Anyone wanna share with me on some of the characteristic of the topology you already learned? Anyone? Bây giờ mình là cái mới mình là cái bên đây anh chạy tìm mà topologyមួយណាអាច describe characteristic របស់ topology មួយហ្នឹងមានទេ Okay. So here I'm not going to describe to every detail of each topology. I just want to point it out what are the topology you already have and how are they how they will be different from one to one in terms of implementation, and it will affect your network, right? Like I said earlier, in terms of scalability and cost and all those things. So this concept of topology will affect depending on your network you already have, or depending on the enterprise you have, and how you are going to implement this topology into the network you already have, and it will affect, right? Less or more, it will affect, and very much the topology is the part or the main component of how it's going to affect in your enterprise network. Okay, so here is I just want to mention what if you choose the right topology for your network, how will it help you? So it's really depending on the enterprise you have, the network you want to build, and all that, the cost, the scalability of the network and everything will decide on the topology which one you will choose. And if you choose the right topology for your network, one of the main thing that is going to help you a lot is the reduced network operational and maintenance cost, right? It will reduce a lot if you don't have a very scalable network, because your network is not going to grow any bigger than this. You're not going to need any updates soon. You're not going to need any monitoring much because you already know your small network. But if your network is going to grow as big, as a 200, 300 people in your network, in your enterprise, maybe star topology or bus topology is something you can think about because of the scalability of the network. Maybe the hybrid one you can think about because you're gonna need a lot of maintenance, so you don't have to wire up and down much because you already know how they work, how they're going to scale, right? So it will reduce your cost. So the cost of the maintenance and operational cost is actually one of the costs that add up a lot in the business because you need a network. You need not just a network engineer. You need a network people where they have to monitor the process, the traffic and everything to make sure you have an optimal state of those network, right? And if you don't, then you need to upgrade and you need to update and you have to know where is the problem and you have to update it. And if you choose the wrong topology, you might need to destroy all your wire you already embedded into your building and then having the different one because you're gonna change your topology. So it's going to affect a lot. So choosing the right topology is really something to consider. One, increased network performance. The increased network performance. It depends on the network you want still, right? The purpose on why you want to build a network in the first place. If you want a high throughput, you want a lot of traffic going on in your network, you might want to have something dedicated, higher bandwidth, different something like star topology might be having a, a good network performance. Or in case you don't have much traffic, not everyone is not much traffic going around. Maybe you can consider bus. Maybe you can consider different topology other than ring or other than star topology, right? Ensure optimal network health by effective allocation of resource. So here, this point is also the part how topology affect the network as well. So here you say optimal health and allocation of resource, right? So you have a you buy the device, you put in the network, and you know the resource is going to be used effectively. Not any resource is left out just to because you don't use much of it, but you buy the big one, so you waste a lot of resource. Whereas you can just buy the small one because it's not much going on in your network. And the third one is the locate and troubleshoot error fast. Okay, because there is always an error in the network. There is always a network error. There is always a network problem, right? So different topology will help you understand and locate it better the error of the network, right? I think it's more likely the star topology is better in terms of locating the error because it's a one-to-one with the switch or network device in the middle. So you will normally able to identify faster. But in terms of maybe bus, maybe daisy chain, those network topology is not effective if you have a big network and you have to allocate error. If for small network, that's okay. You can allocate better, but for bigger one, it's going to take a lot of time to understand and know where the error is. So different topology is going to affect and all the thing. And if you choose the right one, these four main results will help. It's going to help you, right? Reduce your network operational and maintenance costs, increase your network performance, and show your optimal network health, and you will be able to troubleshoot and locate the error faster in your network. Okay, so I think we should take a 5-10 minute break. See After that, we're going to come back to understanding network topology in terms of link and connection. Okay. You can take a 10-minute break. Okay. គ្នាយើងអាចសម្រាកបាន10នាទីយើងជួបគ្នាវិញម៉ោង10នាទីណាម៉ោង10នាទី Okay, we will be back at 10 minutes. Okay. Thank you. Okay. So everyone here? Okay, let's continue and finish our network topology. Okay, so last time I just mentioned a little bit on how if you choose the right topology and how much it will help you, like what are the factor that is going to help you if you choose the right one. Now, going to the next step, talking about link or connection. So in topology, normally you already see the connection on the link between each node in your device, right? Or normally in your local area network, we can say, because here you are planning your local network for your enterprise, for your business or whatever. But it's just a local network of yours, of yourself. So it's the connection and the link is where you play the crucial part of the topology, and the price you pay for that is also pretty much something you should consider as well, because here I mentioned that there are two categories where you can consider the link is possible between your device and to your server, to your router, to each of the device in your network, right? So there are wire and wireless technology. So wire, if you think about wire technology, you possibly already see, imagine the blue cable running around through your building, your selling of the building, right? So for wire technology, normally it's the cable itself is not very costly, but the longer it is, it's pretty much a price you have to be aware as well. And there are different type of cable, including you can see a Ethernet cable, optical one, or you can use a wireless network, right? And these link or connection will affect as well on how much your topology will affect in your network, because it's really something to consider about. Like if you have a network, like you have a three floor of 5 floor network. So there will be a lot of thing to think about if you use wire technology, meaning you have a cable running around each floor for the connection to the computer for your staff, for your people. Or you can have wireless technology where you have a different access point in each floor, and then each floor you consider one local network, and then you can also it's also provide mobility in your network, in your working environment as well. So link and connection is something to think about, uh, of which technology you use. And pretty much it's also affect the topology that you are going to, the topology you already choose as well. Because if you use wireless connection, if you use wireless connection, your topology will mainly change into star topology, because if you see the link in your mind, wireless meaning you have a lot of device connecting into one access point, and your access point will connect to a router or will connect to a switch. If you have a lot of wireless access point, and then just switch the core network will connect to the another core network, right? So it usually seen like that if you use a wireless technology. If you use wireless technology, it will also it will depend automatically on your topology that you design, whether you use burp, whether you use ring topology, whether you use a daisy chain topology. Daisy chain is also a good topology as well, but only for small network, right? So here they also mentioned that the choice of wire and wireless technology for your business network isn't a simple one to make, right? It's not a simple one. You should be aware of that. Although the price appear as the main factor. Well, I guess in all the business, price will be the main factor of anything you're going to decide, because in terms of business, they want to maximize every resource they have and get the most out of it, right? So money will be the main factor. The resource, the financial part will be the main factor in on how it will affect your network. And there are a number of other factors as well you need to consider. Those factors will come with the throughput, the connectivity, the configuration, the scalability, and all that I mentioned last time. And especially for small to medium sized business, around 20 to 100 people in a business. I think this size normally consider medium to small to medium business size. Wireless may offer overall selling. So here they say that wireless may be a better quality network technology that you can consider using. But be aware of this, because if you're building for example, a database server infrastructure, you have a lot of server on your network, on your system. This will be quite a problem. You have to consider that, because wireless might not be a good an optimal choice. Not a good, I wouldn't say it's bad, but the optimal choice for your network itself. Because if you have a lot of system, a lot of service for your internal network, wireless technology is not going to be something that will be very helpful. Although when you say about selling, wireless technology still serve you a lot in terms of small to medium business side. Okay, like they mentioned here. Okay, before going any further, do you have any question? Anyone? Nijen? Ni mechanism nowhere.
Cô network topology muốn nhớ từ bạn cái thờ trên kia là
Okay. Network topology ដែលប្រើច្រើនជាងគេគឺ star នៅសម្រាប់ enterprise ភាគច្រើនគឺយើងប្រើ star topology bus អាស្រ័យទៅលើ sometime bus គឺសម្រាប់ small ណាប៉ុន្តែខ្ញុំមិនដែលជួបយើង implement bus topology ប៉ុន្តែ star topology គឺជាអីដែលត្រូវបានប្រើច្រើនជាងគេ ហើយ tree ហើយនិង hybrid បាទ3ហ្នឹងខ្ញុំអាចថា3ហ្នឹងគឺជា topology ដែលយើងមើលឃើញត្រូវបានប្រើប្រាស់ច្រើនជាងគេនៅក្នុង enterprise តែក៏វា depend ណានៅពេលដែលយើងនិយាយថានៅពេលដែលយើងប្រើ star topology ជួនកាលយើងប្រើ star បន្ទាប់មកយើង merge ជាមួយ tree ណាវាមាន staging នៅក្នុងយើងប្រើ star ហើយយើងត tree ទៅពីលើណាអានោះវាដូច hybrid ចឹងយើងអាចនិយាយថាកន្លែងខ្លះគេអាចប្រើ star ជាប់ហ្មងខ្លះហើយយើងលក្ខណៈ hybrid រវាង tree ហើយនិង star topology តែនិយាយទៅពីរហ្នឹងគឺប្រើច្រើន burst អត់សូវប្រើទេ star ក៏អត់សូវសំដង ring ក៏អត់សូវប្រើដែរហើយមួយទៀត DC chain ក៏អត់សូវប្រើដែរ burst topology វាច្រើនប្រើនៅក្នុងប្រភេទ embedded network ណាប្រភេទ embedded network ដូច LAN ណាដូចប្រភេទ network នៅក្នុង LAN ណា LAN នេះជីណា network នៅក្នុងហ្នឹង network នៅក្នុងប្រភេទ space ប្រភេទ aeroplane ណាពេលលើយន្តហោះអីបើតបជីព្រោះបើវាស្រាលវាអត់សូវប្រើ cable ច្រើនប៉ុន្តែបើសម្រាប់យើង build សម្រាប់ក្រុមហ៊ុនសម្រាប់ក្រុមហ៊ុនសម្រាប់server ណា server infrastructure សម្រាប់ប្រភេទ small network ប៉ុន្តែ crucial ណា nắng cứ bị chán dùng vào star topology cứ popular chẳng kì này sân nô lỏ nó có dân phải đăng này của bây dân cho đây thu cá men té này dân đăng thằng té mùi ná để chỉ tôi tới kịp thời bản implement trở nữa hay đưa nhóm giấy đã to năng implement network nó không aeroplane này nó không dân kho nó không cái nó không làn krong rồi còn lan đại dương bài bỏ ngày đó chẳng ngàn nó nhung comment tên mẹ thọp ở đấy còn là nhung thọp riêng chẳng á chẳng nơi lâu phê bọn nó cứ top boss topology chỉ mẹ đã chỉ topology để cái pra xem mẹ bọn nó chẳng just to mention it's used for different purpose right but for enterprise and for company normally star topology would be the popular one and hybrid I would say hybrid tree and star topology these three topology is the most uh, topology but for like bus topology daisy topology or maybe ring topology because it's the efficient one for this kind of a network and yep these are different usage of those topology any other question some noise in there này này bạn
chơiសម្រាប់ការភ្ជាប់ network ហ្នឹងអាហ្នឹងគេតចូល server ដែរចា
server គឺជា node មួយនៃ network server ក៏ត្រូវចូលនៅក្នុង network ដែរ
ចា
បាទ
ចាបើសិនជាដូចគេអាចតើគេអាចផ្ទុកទិន្នន័យរាល់ការ send data ពី network មួយ network មួយបានអត់ចា
ជាទូបានជាទូទៅគឺអាហ្នឹងគឺធ្វើនៅលើ firewall ឬក៏ gateway ណាតែជាទូទៅនៅក្នុង internal network គឺយើងគ្រាន់តែ monitor ឯងយើងអាច store ព្រោះ traffic ច្រើនណាស់អញ្ចឹងit's not possible ប៉ុន្តែយើង monitor ណា traffic ទាំងអស់ហ្នឹងខ្ញុំដូចជាមួយថ្ងៃគេលុបចោលម្ដងក៏មួយអាទិត្យអីចឹងណាវាអាស្រ័យទៅលើប្រភេទ network របស់យើងនៅតាម enterprise ណាប៉ុន្តែជាទូទៅគេដែរ monitor internal ឯង internal network internal traffic usually internal traffic is not monitored the monitoring process and storage we usually do for the incoming traffic from the outside network right that is how you monitor malicious traffic how you monitor different type of suspicious traffic into your network and those information is stored still it's depend on the device you use if you use a big internal firewall gateway they have a big storage normally they store 24 hour or maybe 2 or 3 or 1 week something it still also depend on your configuration as well right ចឹងគេទូទៅ network traffic យើងអត់ monitor ក្នុងឯងយើង monitor incoming packet ហើយ storage ក៏យើងអាច store traffic ច្រើនណាព្រោះបើយើងនិយាយ traffic មិនមែនមួយថ្ងៃម្នាក់ request តែមួយណាតួ request តែមួយក៏ពី traffic ដែរមិនចឹងទៅអីមកអញ្ចឹងយើងអាច store ទេជាទូទៅគឺអាចមួយថ្ងៃឬក៏មួយអាទិត្យឬក៏មួយខែអីអាស្រ័យទៅលើ configuration ឬក៏អាស្រ័យទៅលើ type of traffic ថាវាសំខាន់ប៉ុណ្ណាទៅលើសម្រាប់ enterprise ហ្នឹងណាអរគុណវិជាមានខ្ញុំឆ្លើយត្រូវសំណួរមិញ មានអីចង់បន្ថែម
បាទចាំបង
ហើយ server ក៏បើយើងនិយាយថា server ក៏ជា computer ដែរគាត់ណាវាមាន storage ធំ computation ធំចឹងទៅតែក៏ computer ដែរអញ្ចឹងបើវានៅក្នុង network របស់យើងវាក៏ត្រូវ connect ជាមួយ network ដែរណាក៏វាត្រូវចូលជា part មួយនៃ network ដើម្បីឲ្យ internal network នេះ computer យើងអ្នកធ្វើការផ្សេងៗ access ទៅកាន់ server ដើម្បីយក service យកអីគេបានណា Normally, the most implemented server in our in internal network is the storage server. Because some business they don't have any, you know, they don't host any website, they don't host any services for other. They just wanna have a what do I say, the central storage for everyone they can access, just so they can share a photo in one folder and everyone can access it. They can share a different file for G and G and G. So this is normally the most implemented one in normal network, normal company, right? It's the storage server. Otherwise, it's not. When I say storage, it's not database, all right? Storage, it can be database, but normally database is different because you use database technology services to store those data, and you normally cannot access from application part. But what I say storage is like you have another computer on Windows operating system, and you share the folder, one of the folder in that computer, to share the storage of that storage, right? But when you say database is a service, you don't normally have access by using application. You normally need another service to connect to that database and then access those database. And it's more on technical part where you use it. So normal, like, I mean, those non-IT people, they won't be able to access or understand those data anyway. So the storage server is the one usually used in the network. យើងពីច្រើនយើងហៅនៅនេះគេហៅ enterprise សំដៅ enterprise ដែលគេហៅថា central computer ណាទៅទៅគេមានអញ្ចឹងមកគេមានកុំព្យូទ័រមួយគេបើលោកណារវល់ទៅ share ក្នុង drive ណាវា wasted ព្រោះយើងត្រូវដាក់ក្នុង drive យើង share យើងអស់ទិញ service drive អីផ្សេងអញ្ចឹងមានតែកុំព្យូទ័រមួយមកយើងទិញ storage យើងធំតិចទៅបើក network access មកហ្នឹងឯងធំតិចតែមកយើង share file folder មួយហ្នឹងសម្រាប់ទៅគ្រប់គ្នាទាំងអស់ហើយក្នុង folder ហ្នឹងក៏ដាក់រូបភាពដាក់ឯកសារដាក់ឯកសាររួមអញ្ចឹងទៅផ្សេងអញ្ចឹងជិតឲ្យតែណាគេ access ចូលក្នុង network ហ្នឹងមានជាផាត់ជា node នៅក្នុង network ហ្នឹងគឺគាត់ access ទៅ folder ហ្នឹងបានណាអញ្ចឹងអាហ្នឹងក៏ត្រូវបាន implement ច្រើនដែរនៅក្នុង network ណាចឹងដូចខ្ញុំនិយាយមិញខ្ញុំនិយាយ storage នេះគឺសំដៅលើអាហ្នឹងណាមិន database storage ផ្សេងគឺយើងផ្សេងមានគេមានងល់អីទៀតណា Any other question? Miss Moi tiếp này. Ok, trên đây tỏ tầm một từng tiếp. Node of a network. Okay. Này, đó là môn tại tỏ nâng server. So node of a network is an endpoint, or you can say a redistributed point of the network, which can receive, create, store, and send data along the network route to the other network node. So here you say there is an endpoint and a redistribution point, meaning the network node or node of the network is not just the end computer or the end laptop that choose the wireless, the connection in the network, right? The node of the network here refer to every device that is not a cable connected to each other. All those things are node of a network. A switch, a router, a hub, a bridge, anything in the network is called a node of a network, right? Because it's either an endpoint of the network or it is a redistribution point of the network. redistribution point of the network will be switch, will be router, will be hub, will be repeater. All those devices are called the distribution point of the network. And the endpoint will be our laptop, our printer, our server, our scanner, and all those things. Maybe later you have a smart air conditioner that going to join the network as well and everything, right? All the device in your network are called a node of a network, but some are endpoint and some are redistribution point of the network, right? So this is something you should know. But another part specifically is the network interface controller. So normally when you say here you say a switch is a redistribution point of the network, but actually switch have a lot of network interface controller, right? Because when you say a network interface controller, if for example if you talk about your computer or your laptop, your laptop itself is not a network node. It can be seen and act as a network node, but it is not. The network node in the computer is actually the NIC, the network interface port or network interface controller of your computer. Normally, it will be your Ethernet port. It will be your Ethernet port, or it will be your wireless point connection, right? So NIC is actually seen as the point where the network is possible. So if you talk about switch, they have a lot of NIC, right? They have a lot of port. So each port they have their own MAC address, right? They have their own MAC address. So the connection is between each port. So here I just want to point it out that you have to understand when we talk about the node of the network. You can consider a computer is a node of network, a switch is a node of a network. But when we talk logically, or you can say as it be seen, the computer is not the node. Computer, because it's a big chunk of hardware connected to each other, one of which is a network interface, where they connect the network interface with another network interface with another network interface in the network, right? So this is something you have to know. Okay, so next point, talking about network interface controller. Apart from advantage and disadvantage of each topology that I haven't mentioned, but I'm sure you are aware of all those, the cost is likely to be critical consideration in the choice of network topology, right? So the cost is like I said, like I mentioned repeatedly, because it's really the core of the business, right? So beside the advantage and disadvantage of the topology, the length and type of cable will affect your network. The hardware will affect your network. The scalability of your network will affect the network. So here the length and type of cable. So here they say the more the cable required to build your network, the more labor intensive. Labor intensive. Remember, you are not the one who embedded the wire into the building and then connected to another. There will be another people who will do it, but you are the one who plan it. But you will see that if you have a lot of cable to build your network, the cost of the cable itself is small, but it's a price to see how much it is after you completely install your network. This is always a big thing. Remember when I talked that bus topology is normally used for airplane and car, because it's not heavy, because you just want put one big cable, and then you connect from that big cable to a small cable for the node in the network, right? So it's less heavy, and it's perfectly good for car bus and then all that, because you don't want to having a lot of cable running around your car or the airplane, right? And it will reduce the weight of all those things as well. So here the length of the and type of cable will be surprisingly expensive depending on the topology you are going to use. Like if you see the mesh topology, it's a horrible thing that you have a lot of cable running around in your network, right? So and it's the type of the cable also affect as well, because maybe you have a twisted pair cable. You have Ethernet cable, that one. You have a coaxial cable, or you have a fiber optic cable, right? And each one is they are different in terms of price and the bandwidth they are able to transmit in the network as well. So the more the quality, the more the bandwidth, the more expensive you are going to spend on the cable and the lane as well. If you have a very wide building where you have different node lying around different places in the building, you're going to need a very long cable to connect from one node to one node in the network. That is going to be a lot more expensive, right? Because if you consider 1 meter of the lane, maybe cost $1 or something. If you have a 2 meter, you will pay $2. It's a double of your price, right? So if you have a 10 meter and then instead you have 20 meter, the price is double, right? In terms of the network you have. So it's going to be very expensive. The hardware, yep, in certain type of network topology, the network performance or bandwidth are limited by typical specification of central hub. Here, the central hub refers to the redistribution point of the network, which is switch, which is a router, repetitor, or hub in the network. And those new hardware are expensive, are very expensive, right? If you are not aware, it can go up to $10,000, $20,000 of those device. There's a cheaper one as well, but there is a different in terms. You have the modern switch. You have the modern one with the embedded software and filtering system and all that in the new switch, and so it's going to be very expensive. Or you have a very low cost switch where it doesn't know anything. It's just switching around for the traffic, right? So you have to consider the hardware in your network as well. I mean, like I said, document like the whole thing, the processing, the hardware, the database, and everything, every little detail of the network, of the device in your network, so that you can choose the one that is perfectly fit and cost effective in your network. So hardware is something really consider about, not just the central hub, like I said, even the network node, the computer, the laptop that you are going to uh, give to your people or your staff to work with. It's going to affect the price as well. So make the best consideration of those things. Another one is scalability. If for the company that plan to grow, it's highly recommended to use topology that is flexible and can be easily expanded. Yep, it makes sense. If you are going to grow and a lot faster than you intended, or a lot the network of the growth of your network is out of your mind and you're not thinking of it, you're going to mess up, because the topology you use is not scalable, and then you have to rip up the whole network. You're gonna destroy everything you have, the cable and everything, take it out of the building. It's going to cost a lot of labor. It's going to be a lot of labor work in terms of that. So it's very effective to think about the scalability of your network. And like if you remember what I mentioned earlier, is that Wi-Fi wireless technology is kind of very good and very cost effective for a small to medium network and plan to grow, right? Because it's cheaper, you can easily change your topology. But if you choose the perfect one already, and then you know that you are going to grow in which side, in which term, then you already keep those part where you can expand. Then it's perfectly fit. I mean, perfectly good for your company, right? Because you already know where it is. You don't have to rip out everything. You just continue building on it. You don't need to pay to spend a lot of intensive labor for all the work that you need to continue to build the network. So it's less expensive. So that is better, right? Okay, so this is one of the examples, or you can say the how normally it is implemented. For mid-size network, mid-size, you can say small to mid-size network. They say 50 to 200 user in a network. A common way to design the network topology is to use the two-layer switch architecture. So what is the two-layer switch architecture? This is the two-layer switch architecture. For network topology, if you have this same amount, this is not the actual best practice, but it is the document somebody have implemented, have planned out, right? So they say for the mid-size network, for 200 or less, you can use the two-layer switch architecture. The switch architecture here, because there are two layers, meaning there is a core layer and access layer. The core layer here contains a high performance switch that connects to server. And if you see here, this is the core layer. This is normally the implementation that has been done. So you have a switch, two switch as a core layer, and connect to our server, the server in the system. And presumably, because this is a local network, the local area network, you will need a router as well in order to connect to the external network. So this is the level where you see in the LAN, in the local area network. So the core layer network is contain a high performance switch, connect to the server, and this connection should be as fast as possible. And they say ideally 10 gigabit per second. And normally that will be a fiber optic copper connection. Okay, that's good. So this is the core layer. Normally they need a high performance switch, because if you remember, every NDY here will send the traffic to this switch, and this switch and this level switch, access layer switch, is going to have a lot of traffic coming into them, right? So they do a lot of switching to this core layer. So these two core layer need a very fast or speed. And a very good computation switch for this core layer. And for access layer, they can have a different switch, like I mean the low performance one, so that it's not expensive. And but they want a more port switch maybe, because it depends on the network. If you have a lot of switch group of the network, meaning you have more than 20, 50 computer, 100 computer, 100 N device. So you need to connect them to different switch, right? So that is how they connect with each other, is connect to another switch. So this is something usually implemented in mid-size network range, right? Okay, so today we finished the network topology, which is one of the part in network in planning a network. So choosing the network topology, understanding how it is going to affect your network, the price you pay, the cost effective, the scalability, the hardware, and everything in the network topology is something you have to really consider about, which is the initial part of network planning. So choosing the right network topology will affect the whole network going forward, and the future of your network as well. Okay, so that is the end of my course regarding the network topology. Do you have any question? Mình dùng đôi cái này chứ. Lươn bây giờ.
Mình sơ vô cái này call network.
Core network à? Core network mà.
Bạn.
Trên core network thì tôi tới cứ đây xa tay bờ sân thì riêng chạy là lớn mid-size network á, vì thông á. Trên connection chở nè. Cái cho mà chẳng bờ sân thì riêng connect pi switch dương khơi mà nhá. Bờ access layer bờ dương á, access layer bờ dương. Computer chán connect từ về chẳng traffic chán ra chỗ về. Tao máu viết level access layer này bởi vì connector router mà cướp cả tề của traffic nó cứ tràn này chẳng về handle cả đây chẳng gì tôi tới thì mình call layer mới tiền nó thẩm mid size này nằm phải để lang đó level là pi rồi tiết khi mình street tier level switch cứ dùng vào switch mũi thì chỉ call layer access layer call layer hay miền là computation layer sầm map môi switch pi tiết cứ xong tỏ miền switch từ 4 miền 4 miền vào mỗi tao mà miền 4 tao miền pi rồi còn miền 7 hay miền pi cứ map pushing process này là traffic này bây giờ dùng miền traffic chọn còn ấy đây làm khác này dùng thành vô là access layer cứ layer đây connect to thì mới cùng tờ call layer cứ chỉ layer đây connect từ căn router rồi từ căn server bằng nơi bây giờ viết chất trên từ khéo network của cái này năng computation với chở này sang traffic trên pi nâu máu pi access layer mà chẳng hạn Paul nói bạn chỉ miền call layer switch mới tiếp xong map bill là thua computation này năng processing này lên trên call layer cứ cần switch từ cănประเภทend node ដូចជា server ដូចជា database server database storage ទៅកាន់ computation power computation computer super computer អីហ្នឹងគឺយើងប្រើ call layer switch សម្រាប់ connection access layer គឺយើងប្រើ switch ធម្មតាដើម្បី connect មួយ computer ដើម្បី traffic រត់ណានេះតែប៉ុណ្្នឹង តណារត់តាឬក៏ខ្ញុំនិយាយផ្សេងច្បាស់
លោកគ្រូថាលោកគ្រូនិយាយ call switch អាហ្នឹងលោកគ្រូនិយាយ call switch គឺនិយាយ call របៀបខ្ញុំក៏តើស្គាល់ថាលោកគ្រូថាយក switch ហ្នឹង connect ទៅកាន់ server ហើយលើកស្ថិតនៅក្នុង level LAN មួយក៏និយាយទៅកាន់
LAN នៅតែ LAN នេះនៅតែ LAN នេះណានៅតែ LAN នេះពេលអានេះអត់តាក់ទងជាមួយនឹង level នេះណាអានេះនៅក្នុង LAN មួយប៉ុន្តែក្នុង LAN ហ្នឹងវាមាន level network ទៀតចឹងបើសិនជាយើងមើលក្នុង tree topology គឺយើងឃើញអញ្ចឹងហើយ three topology យើងមាន divide មួយ connect មកកាន់ មេធំមួយ ហើយមេធំមួយហ្នឹង connect ទៅកាន់មេធំមួយទៀតឃើញហ៎ឃើញ three topology ហ្នឹងហើយcòn នេះគ្រាន់តែជាឈ្មោះដែលគេ mention ឬគេដាក់ឲ្យនៅពេលដែលនៅក្នុង level ប៉ុណ្ណឹងបើសិនជាយើងប្រើប៉ុណ្ណឹងគឺយើងមាន access layer យើងមាន core layer
បានលោកគ្រូអរគុណច្រើនលោកគ្រូ
មានអីទៀតហ្នឹងមានសំណួរផ្សេង Any other question No Okay, so that is the end of my class. Thank you very much. And I see Pepe Group A in the afternoon, right? Okay, thank you.